So most of you guys will be in mostly in final year or so, or who will be repeating gate and everything, right? So we will discuss, like, if you guys know like few concepts. Like what I was thinking is, like, I will just like float one question on my screen, and I will give you like 2-3 minutes to solve that question, and in chat box you can write the answer of that question. And if you don't know the concept, or the concept is not taught to you till now, then you can just write not heard of this question, or not like I cannot recall this question. Just like that, you can just write in chat box, and after 2-3 minutes we will like go through the question, and how, and you can check your ability whether you can solve that question or not. Like that we will proceed. So today we will take let's say four questions. First, let me project my screen. Just give me thumbs up or yes whether you can see my screen or not. Okay. So welcome all to this second session of Get NPTEL Metallurgical Engineering. I will be hosting this second session. Actually, 4 people are there who will be hosting these NPTEL sessions. So this is my second session, and we will be talking regarding the previous year GATE questions, which is GATE 2016. So I am Swanand Telpande. Let me introduce myself. I am a PMRF research scholar in ISC Bangalore, currently doing PhD, and I am in final year of my PhD. So this is the deliverable which is given to us from the PMRF, and we are doing that for you guys, like to like make people more aware of GATE and how we can solve these questions very easily. So let me begin with this. Now what I will do is, like, I will project first question, and you need to answer that in 2-3 minutes, and then we will go through the solution of that question. So just a second. Yeah. Can you see the question?
Yes, sir.
Yeah. So you have like let's say 2 minutes from now, 2-3 minutes to solve this question. And you just a second. Now you can solve this question, and I have given this beautiful image also to give you some hint. You just try to solve this now for 2 minutes, then we will solve this question online. Yeah, 1 more minute, and then we will start with the solution. Shall we start with solution? Are you able to solve that? Okay, I can see one answer till now. Okay, 2 minutes more and then we will start. I will again project the question. Okay then, let's start. So this is GATE 2016 Metallurgical Engineering question number 48. A glass plate has two parallel cracks. One of them is an internal crack of length 5 micron and other is the surface crack of length 3 micron. A tensile stress is applied perpendicular to the cracked surfaces and we have to find out the fracture stress in MPa, and the given data for glass plate is Young's modulus is 70 GPa and surface energy per unit area is 1 joule per meter square. So let's consider this as a crack plate which is consisting A1 as the surface crack and twice of A2 as a internal crack. So we know that A1 is 3 micrometer and 2A2 is 5 micrometer. So A2 becomes 2.5 micrometers. Now we have to consider a crack which is longer in length so that the fracture stress is lower. Hence consider calculating the fracture stress for crack of higher length. So we have to neglect 2.5 micron crack and we have to consider 3 micron crack which is a surface crack. Now you know that using Griffith's theory, fracture stress is given by under root of 2 Young's modulus into surface energy per unit area divided by pi into A1. We have considered A1 here. So when you put these values in the equation, you will get the value of 122 MPa. So this is the correct answer. Do you have any question in this question, like any doubts or so?
So why did you made it as 2A2?
Yeah, so internal crack is basically you can, like, I will show you here. You can see in this figure internal crack, as you can cut this geometry, internal crack will become a surface crack of length A2. So when we consider internal crack, its length is not A1 or let's say A2, it's twice of A2. You can have, so when the stress concentration will be there, it will be here also and here also, and in surface crack it will be only here. So we have to consider only half of that. So one portion of the stress concentration, not both the sides. That's why the internal crack will be always twice of A2, not A2. You have to remember that. And surface crack, as you are pulling this from both the sides, the stress concentration will be only on one side. Hence we have to consider A1. So let's say if you like mirror this geometry to the left hand side of this boundary, so this A1 will also become A1 here. So this will be twice A1 and it will become an internal crack. So you have to consider that. Always for internal cracks use twice A2 or twice the size which they have given. Like twice the size is 5 micron, so half of the size will be 2.5 micron. I hope this is clear. Is it clear?
Yes, sir.
Yeah. So any other doubt in this question before we proceed to another question?
No, sir.
Okay. So let's proceed for another question. I will give you like again 2-3 minutes time to solve it. Let's see whether you can solve it. Then we will discuss what is the science behind that problem. So similar questions will be there in gate also. Like these questions most of the times repeat with by changing the values. So if you know how you can calculate that, you can like get the answer very easily in like less than 1 minute or so. So don't spend more time in this question. Like this is a fundamental question, only one formula you have to just add. But make sure that you use the gate calculator, like you have hands-on practice on that gate calculator, which is the online calculator. Sometimes the units may mismatch and you may get some different value. So this is the another question. So I will give you 3 minutes to solve this. This is basic crystallography question, and you need to find out the surface energy per unit area for two planes, and you have to take the ratio of that. So I will give you 3 minutes to solve this. Does anyone of you know the concept? If you can share with us, all of us, how we can solve this. Anyone got the answer? Root 3. Okay. 1.41. Okay. Anybody else? I will give you one more minute. We have to just find the surface energy of 100 plane and 110 plane in a BCC crystal, and we have to take the ratio of that. This question comes repeatedly in GATE. Like you may know that FCC crystal, BCC crystal, different planes. Like you need to focus on three main planes: 100, 110, and 111. You need to know like how these planes are arranged in a BCC and as well as FCC, which is the closed pack plane and which is the open plane. That thing you need to know. And what is the basic funda of surface energy, like why the surface has some extra energy than the bulk, that you need to know. In this, three concepts are there basically. So I will go through each of the concept. I guess enough time is given, so I will proceed. Okay, so here we go. This is GATE 2016 Metallurgical Engineering question number 50. For a BCC metal, the ratio of the surface energy per unit area of 100 plane to that of the 110 plane is. So we have to give one value which we have to find the ratio between the 100 plane surface energy to the 110 plane surface energy. So the surface energy per unit area gamma is given by half of NB into epsilon into rho A, where NB denotes the number of broken bonds to create the new surface, and epsilon is the bond strength, and rho A is the number of atoms per unit area. So if we consider the BCC crystal, here you can see I have shown you 100 plane and I have shown you 110 plane. Now if you consider this, so this is the 100 plane which contains 1 by 4th of atom, like 1 2 3 4, and the total number of atoms if you calculate will be coming 1. So this is 1/4 1/4 1/4 1/4, and here similarly 1 is the center atom, and here there are 4 different atoms. Hence now you have to find out, if we cut through this plane, how many bonds will be broken. So this is 1 by 4 1 by 4 1 by 4 1 by 4. So number of bonds broken to create new surface will be 1 here. And similarly here, if you see, so if you cut by this plane, these two bonds will be gone, these two bonds. Hence you are cutting only 2 bonds here, and here you are cutting 1 2 3 4 bonds here. So for 100, if you put with this, for 100 half of into 4 bonds you are breaking, especially 1 2 3 4 of the crystal. Like if you can imagine, out of this plane similar crystal will be there and you are breaking this 4 bonds. So here 4 comes. Epsilon is the bond strength, we don't have to take care of that. And here we have to calculate this area, which will be A square basically. So number of atoms, atom is only 1 here, 1, this is 1 by 4 1 by 4 1 by 4 1 by 4. So 1 atom divided by A square, the area of this plane. Similarly for 110, gamma is given by the same formula. Here number of broken bonds, as I told you, if you can cut from this 1 2 bonds will be broken, epsilon remains same, bond strength, because these are the same atoms. And here as you can see, number of atoms will be this complete one and this 1 by 4 1 by 4 1 by 4 1 by 4. So this accounts for 1 and this complete 1. So 2 atoms divided by this will be root 2a and this will be a. So root 2a into a, so root 2a square, and this becomes root 2 of 1 by a square. So if you take the energy ratio, here you can see this is 2 divided by root 2, which is 1.414. This is the answer. So you got like how we can do this? हाँ सर, मैं मीटिंग में हूँ थोड़ा. आप हाँ हाँ हाँ। नहीं नहीं, 8 mm तो नहीं चलेगा। भैया मैं आपको थोड़ी देर में कॉल करूँ क्या? मैं मीटिंग ले रहा हूँ। हम्म, हाँ हाँ। ओके। Yeah, so you got this question, like how we can solve this. If any doubts, you can ask me. Okay, so the question is, how can we take 1 as the contribution of body center atom? It should be half. Okay, so if you see a 2D image of that 100 plane, 110 plane, I will show you. So if I draw here 100 plane, here one atom is there, here one atom is there, here one atom is there, here one, and here one. So this whole is root 2a, and here this is a. So now you can see this is a rectangle, so this is a 90-degree angle. So this is 1 by 4th of atom, this is 1 by 4th, this is 1 by 4th, and this is 1 by 4th. So this makes 1, and you can see in the 2D projection this is complete 1, this is not half, or this is not 1/4. So this is one atom, and this is another one atom consisting of 4 1/4 atoms. So here 1, and this 1/4 of 4 atoms, which consist of 2 atoms. And here also similarly you can see this projection will be a square consisting of 4 atoms. This, this, this. Now you have to see how much comes into this square. So this is 1 by 4th, 1 by 4th, 1 by 4th, 1 by 4th. So it accounts for 1 atom in this plane, and this accounts for 2 atoms. I hope I cleared your doubt. So you have to take a 2D projection. Chintu, did I clear your doubt? Okay. So let's proceed to another question. Uh, Again, this is a numerical. I will give you 3 minutes to solve this. Okay. Solve this question. This is related to casting. Okay, 1 minute more and then we will start. And you just make a note of these questions, like these questions are repeated regularly in GATE metallurgy. So you should be knowing these formulas which I am discussing right now. So you can easily get 2 marks out of this mostly all 4 questions which I will be taking today, I am taking now, are 2 marks questions, and you can solve it easily in like 30-40 seconds. So make sure you know all these formulae which I am using right now. Similarly, we will be taking such problems in next session also. Today we are taking 4 questions. So better keep a note of this formulae for future and revise these formulas easily later then. Okay, let's start then solving this question. This is GATE 2016 Metallurgical Engineering question number 52. In a sand mold, a sprue of 0.25 meter height and a top cross section area of 2.2 meter square is provided to maintain the metal flow rate at 4 meter cube per second. To prevent aspiration of molten metal, the maximum cross sectional area in meter square at the base of the sprue is. So we have to calculate the maximum cross sectional area at the base of the sprue. So as you may know, sprue is like a chamber. I will just draw it here. So sprue consists of this and this. So it will be connected like this. So, and from here we pour the molten metal. So they have given us the top surface area AT, which is 2.2 meters square. Now we have to calculate AB. So we have to calculate this. So firstly we should know what is aspiration of molten metal. The pressure in the liquid metal stream being moving through the sprue should not fall below the atmospheric pressure. So here P1 and here P2. P1 and P2 should be same. If these are not same, then atmospheric gases can be absorbed in the molten metal and in low pressure areas, and this phenomena is known as basically the aspiration effect. So let's say if this phenomena occurs in casting, then our casting will be porous. Most of the like the regions will have some porosity because of these gases. Hence we want to avoid this. So if we have to avoid this, we have to design a sprue in a such a manner that no aspiration takes place. So given is that the flow rate is given 4 meter cube per second and height of the sprue is 0.25 meter. So we know that because of continuity equation, the flow should be equal from top also and bottom also, so that no gas can enter. So A1 V1 equal to A2 V2, and V2 is given by root of 2gh, and this is the derivation of from the Bernoulli's principle. You can refer to Bernoulli's principle. It is a small concept where you can find out that V2 becomes root of 2gh. Hence if you find out Q, we know that Q is 4 and A is the area, like final area, into root of 2gh. So G is 9.81 and H height is given as 0.25, and we have to find out the area. So area comes out to be 1.806 meter square. Here the top cross sectional area, which is like 2.2 meter square, the value was not required. So in case the flow rate is not given, then you can use that value also to find out the final answer. So you have any doubts here, like how we can calculate that? Yeah, so air aspirations means like let's say you are like having a molten metal as well as air surrounding that molten metal. So let's say if pressure drops, what do you mean by pressure drops? Like if the continuity of molten metal is not achieved in a sprue, then what will happen? The if the pressure is low at certain regions where the molten metal is present, so this gas will try to get absorbed in the molten metal, and if this molten metal gets solidified later, then this molten metal or the solidified workpiece will contain porosities because of this absorbed gases. So in order to have a like less porous or casting with no porosity, we need to have a continuity, and we need to design a sprue in such a manner that no aspiration takes place. I hope this answered your query, Prasanna. Okay, if you can go to Bernoulli's principle, then you can be able to like more appreciate this thing, like how it will be. Please explain stating this solve means. Can you just unmute and just tell me what you want to ask? Okay, I will get back to the question. So here what they had asked is like let's say we don't want any aspiration in the sprue. So the sprue is always tapered, like it is broader in top section and it is narrow in bottom section. So because of that we require a certain flow rate, and that flow rate is constant, right? So to avoid aspiration we require same pressure at top also and same pressure at bottom also, and we also require continuity. So in order to know that, like avoid aspiration of molten metal, so we have an exact cross sectional area of the base, it should be maintained. So what the question is asking is that they have decided the top cross sectional area, they have decided the height of the sprue, and what they want us to know the area of bottom base of the sprue, so that no aspiration will take place. And they have given that we are pouring metal at a melt flow rate of 4 meter cube per second. Now we have to calculate that. That is the basic question which they are asking. So we have to just use Bernoulli's principle and continuity equation to get the answer. It's a basic simple formula. So if you want more insights, you can like refer to Bernoulli's principle, how it is. Complete derivation of like V2 equal to root 2 GH will be there in that. Maloth, you got the point? Okay. So now we will go to last question for today's lecture, and this is the match the following question, which you will, I guess most of you can solve this. This is from the manufacturing processes, different manufacturing process. This is also a 2 mark question. So if you have knowledge of all these processes, you can easily solve this. So I will give you like hardly 2 minutes to solve this. Just text like ABCD which one of the option is correct in chat box. ACCC. Okay. Other guys also try to solve. It's an easy question if you have studied any like these processes, manufacturing processes. Otherwise, I will just discuss like what these processes are. Most of you are like good. Okay, so most of you have guessed it. Let's start with this question. So this is GATE 2016 Metallurgical Engineering question number 55. Match the deformation processes in column 1 with the corresponding stress states listed in the column 2. Column 1 is wire drawing, forging, stretch forming and cutting. And column 2 is direct compression, indirect compression, tension and shear. So before proceeding to answer this question, we should know all these four processes. First is wire drawing. So what is wire drawing is like when we apply an external tensile stress which induce two mutually perpendicular compressive stress. So if we try to pull one thing out of a narrow hole, then what happens is like because of that narrow hole, two mutually perpendicular compressive stress acts, which indeed gives thinning of that wire, and we can be able to draw wire of lesser cross section than the earlier one. So which is wire drawing. Here we are applying a tensile force, but which is giving compressive stress near the hole, which is indirect compression. So P corresponds to 2. Now what is forging? In forging, the force is directly applied to the surface of workpiece, so and the metal falls at right angle to the direction of the compression, hence it is basically a direct compression. So Q is 1. Now what is stretch forming? Now you can see this schematic. This is the sketch forming, stretch forming. Here you can see one die is there, and here you have a sheet, and this sheet is holded by these two carriage. They usually call it carriage, and this ram or this is fixed. So what is usually done is like we pull this two and we pull this two also, this also ram also. So what it does is like you can see this is stretching this plate or sheet, and again ram is also like stretching it more. So this is a type of tension, like in this sheet tension will be there. So R will be 3. And cutting, as you can see in this schematic, this is the workpiece and you are like parallelly shearing force, and the shearing force is out of the plane of the sheet, which means that it will cut like this. This die will go up and this die will come down, hence this is a shearing action. So cutting is basically the shearing action. So the answer is wire drawing is indirect, so P2, forging is direct, Q1, stretch forming is tension, R3, and cutting is shear, S4. So the answer is option C. I hope this is clear, I guess, to most of you. If you have any doubt, you can ask regarding all the four questions. Like we have finished all the four questions. Now you can ask me like any general doubt or so, or like what we can have in next session, so that you will understand few things better which you couldn't understand today. What topic? Like I mostly cover on crystallography, solidification, mechanical metallurgy, few physical metallurgy questions. So more or less I cover most of the things. So it's not like a dedicated session to any particular topic. So you will be able to know all the you will be able to get the crux of everything. Which book shall we read for mechanical metallurgy? So for mechanical metallurgy, one good book is Courtney, Thomas and Courtney, and another one is Dieter, which usually people follow in BTech. So these two are pretty good books you can refer to. Next session will be on next Wednesday. Like I will host that session. Few more sessions are there which will take again like same 2016 different questions of 2016 paper. So those will be on Friday same timing, and two sessions will be on Saturday. So and but those will be hosted by some different fellows, and I will host next session on next Wednesday same timing. Any other doubt? So this thing helped you or not, like giving 2-3 minutes to first solve the question by yourself and then coming to the solution, or else I should start directly? I guess this helps to like make you think something regarding the question. Okay, it is helping now. Okay, it's okay to like not know the concept behind that, because you are in final year. Like most of the things would be covered, but few things are there you may not have covered those things. So it's okay to like just say that okay, I have not learned this thing. So we can go through the question and you will be able to know like what is the concept behind that, and those who know can attempt the question simultaneously. So this thing will help. Now you have to like work on like how you can increase the speed of solving questions. Like in 3 hours you have to solve almost like I don't know, like 55 or 65 questions. I'm not sure regarding the questions, but you have to know like which question will take time and which question you can easily solve in like less than 30 seconds or so. So you have to make sure that these formula based questions which I took today are like hardly simple mathematics if you know the formula. So it should not take you more than 30-45 seconds to solve this, and these are like well rewarding questions also. You can get easily two marks from these questions. Sir, in first question, if we have two surface cracks of same length, so we will take anyone. Yes, you will take any one of them. So let's say another case is like two surface cracks are there of dimension, let's say 5 micron, and another one is of 8 micron. So you will have to take a larger crack. So you will take into account in the equation 8 micron crack, not a 5 micron crack. You should always remember, because the stress concentration of the higher length crack is more as compared to that of the smaller length crack. So the higher length crack is more prone to be consisting of fracture stress, so that fracture occurs of the complete material. So the larger crack will like crack first, then the smaller crack. So nothing will happen to smaller crack, only the larger crack will grow and eventually the material will fail. So you have to consider always the larger crack, and in internal crack you have to take it half value. Always make sure that. Any other doubt? If no doubts are present, then we can like stop this session now. Okay then, thank you everyone. We will meet next Wednesday, and another sessions you can also join from Friday and Saturday. Thank you everyone. Okay, see you next Wednesday. Yeah. Okay, one more question. For transport phenomena, which NPTEL lecture series should we follow for GATE? Uh, Firstly, I don't have any access to NPTEL lecture series, which is some different thing than what I am in another thing. So I guess some links would be shared to you regarding the teaching materials. Some online videos would be shared with you. In that videos, most of the links will be depending on the topic wise, like topic wise links are given. So I'm not sure regarding which link to follow. I guess yes, like lecture series videos are available in NPTEL. I will tell you in next session. Like I will have some links for you guys. Then you can like just attend those videos. Like all the concepts will be explained there, but they won't solve any questions. So questions we will solve, and concepts you can build in that like lectures. So I don't have a link right now. I will get back to you in next session for that. For metallurgical thermodynamics also, I will share you the links of the lectures. These will be mostly NPTEL lectures dedicated towards the gate thing. Any further questions?
No, sir.
Okay. Okay, then see you guys next Wednesday. Okay, bye bye.